So, continuing with our HTML5 canvas videos, I'm going to show you how to do polygons, and also I'll use the Skew transform. Wanted to thank Connor Esslinger for helping me with the Skew. He provided the code for that. Okay, so I found a really good tutorial on drawing polygons with the HTML5 canvas primitives. I was kind of surprised that they didn't have these primitives in the language, but it turns out that that you have to basically calculate the points and use trigonometry to do this. So this link explains this, and it had some code which I then modified a little bit. So the key to this is to recall that a regular polygon has points on the edge of a circle with a given radius. And so we can use the known radius and the known angle, which of course is 360 degrees divided by the number of sides, and then use the sine and cosine trig functions to calculate the coordinates of the x and the y points for each of the points on that circle. And then it's just a matter of drawing straight lines to connect the points. Now, one interesting thing about this is we use our translation function that we've seen before to translate the origin to the center of the polygon when we're drawing it. And there's an interesting trick to use here, which is called the draw stack, where we save and restore the stack of the drawing. So you'll see that here. Okay, let's take a look at our code. You know, I changed my mind. I've got the web browser open. Here's that site I was telling you about, Storming the Castle, how you can draw regular polygons with the HTML Canvas API. This is a blog by John Robinson, and it's really helpful. So here you can see the polygons in the circle where it shows how the points are on the circle. And then here's John's code. And you'll see that I've used the code, but I've just modified it a little bit. It actually makes good sense to pass the graphic context into the function because you can have more than one canvas on the page, so you'd have two different contexts. But for what I'm doing, I've just gone ahead and modified that to use my global context, which is called G2. Again, here's the explanation. So you can see we're taking the cosine of the angle times the radius to get the x-coordinate, and we're taking the sine of the angle times the radius to get the y-coordinate. And then, of course, that formula assumes that you are at the origin, so he's done the translation. Okay? So it's a really good tutorial and explains how all this works. And the code will actually work very nicely when you plug it in here. So let's go now to Dreamweaver, and I have the code open here, and for this particular one I have my render button, and I've set it to basically start an interval where it will continue to generate a number of polygons that have random position and random radius. And then I've also added the Skew button to apply the Skew, and I'll show you how that works in a second. Let's take care of the polygons first here. So let's go and look now at the JavaScript code, and basically you can see I'm grabbing the canvas. I've got a timer here that I'll use for the Skew. I've got the seconds for the timer set. I've got some stuff here from the old program that I'm not using, so I'm not going to write any text or anything. We're going to get the context. We have a variable called number of sides, which is global. It doesn't have to be. That could be local to the draw method. We're going to draw 20 figures. That's what total lines is here. And here I'm randomizing the x and the y, which is going to be the center point for the polygon. When I was getting this debugged, I just set that to the same point, which is the center of the screen, so I could play around with the parameters and get the figures the right size and all that. So here in the loop, we're going to go ahead and begin a path. Let me talk for a second about how I get these numbers. So you can see that math.random times canvas width is going to give me a value from 0 to the length of my canvas. And right now that's 800 by 800. And what I've done here is I've reduced that, so by 0.80. So now that's going to be from 0 to 20% less than my width and height. And then I add the 80 back in there, which centers it. So effectively what that does is that creates a border on all four sides of the canvas where I won't have a radius, a center point. And then basically what that does is that ensures that I'm not drawing off the screen, that the figures that I'm going to draw will fit into my canvas area. So it's a pretty easy way to do that, a kind of off-the-cuff calculation. Line width is the same here. I've got it set to a minimum of 3, so it's going to have a range from 3 to 12. And then the radius, again, I took 1/8 of the canvas width and just added 25, so I had a viewable item if I got a real small value. So again, that's going to range from 25 to 125 basically. We're getting random stroke and fill style. You've seen this before. And now this is important here. So here's the polygon call. Let's go down and look at the polygon function first. Okay, so the polygon takes the x and the y, which is the center point, the radius, that's how wide it'll be, and then how many sides it has. And we begin path in here. We go ahead and again, math.pi times 2 is a complete circle, and so number of sides will give me in radians the angle. That's not in degrees, that's in radians. Okay, so there are 2 pi radians in a complete circle. If we divide by the number of sides, that's how many radians are left, and that becomes our angle. But the angle is in radians here, not degrees. Here's the translate method that I talked about, and so it's going to temporarily translate the coordinate system to the center point of the polygon, and then we move to the first point, and basically that's going to be the radius on the x-axis, which is this way, and 0 on the y. So the first point is going to be on the horizon, if you will, basically directly to the right of the center point of the figure, and then the rest of the points will rotate around from there. So one way of thinking about this is we're going east for the first point, and then we draw the rest as we go around. Okay, so that move to sets up the first point. From there we line to the second, third, and the rest of the points. Here's the calculation that we just saw in the tutorial there that I looked at. So we're taking the cosine of the angle, and I is how many, which point it is really. So the first point here is going to be 1, which will be that angle times itself, times 1, that angle. And then when we take the cosine and times the radius, we get the x. We take the sine times the radius, we get the y. And then the next time this will be 2, and so it'll just basically increase the angle as it goes around the perimeter of the polygon. Once we've got all of this drawn, the closed path joins the penultimate, or the last point, pardon me, the ultimate, the last point with the beginning point, and that closes the figure. Now, this is kind of important, and I'll show you what happens when I don't do this. I don't want it to screw up the global coordinates, so what I do is I save and restore the current context. Otherwise, the translation that's done within the function will screw up the location of the general drawing. And I think I have a single translation here. Let me look and confirm that. Oh no, when I first did this I had a translation because I drew everything from the center point. but now it's randomizing the points. Okay, let's take a look at it and see how it works. Again, I have this set. I'll reload it real quickly to use the timing function, so it'll keep calling draw. So there's the first one, second, third, etc. Okay, so you can see it's just going to keep filling, and we'll do the skew in a second, but I want to fiddle with a couple of the parameters here so you can see what happens when you don't save the context. So again, the idea here is that I save the current drawing context, then use the polygon to render the polygon, fill and stroke it, and then restore the context. If I don't save the context, the translation within the polygon method becomes global, and then it screws up the drawing. So you can see this in a second here. I'm going to run it now with the new settings. So we'll reload and start it. And again, it works the first time, and then basically now things are kind of being drawn off screen. Okay, so that doesn't work that way. Alright, let's fix this, put it back, and then I'll talk a little bit about the skew method. Oh, just to be clear here, you can see that within the polygon method, to show the border, I first, where is that? Pardon me. Okay. So this draws the polygon into the graphic context, but it doesn't render it. And then because I want to show it with the border, I fill it first and then stroke it. And you can see that because we have two different colors. Let's turn the stroke off and run it again. So we'll go ahead and save this. And then go back into Firefox where we're previewing it. Reload the new code and start. So there are the filled polygons that they don't have a border. Okay. Again, let's stop this. Go back in. Restore the stroke, which again occurs after the fill. It's really important when you want to do this that you stroke after the fill. Otherwise, the fill will overwrite part or all of the stroke, and then you won't see your border. Okay, here. Whoops, keep losing my mouse. Come on. There it is. Reload. Start. And we're back again where we're drawing our border. Okay? Alright, now let's look at the Skew code. So I'm going to stop it by reloading it. And we'll pop back into our code. So as I mentioned, Connor Esslinger gave me this code, and this turns out to be a fairly elaborate transformational matrix, which is based on linear algebra matrix manipulations. And I've got to be honest with you, it's been a long time since Tom took linear algebra, and so I'm not real good at it. But this is actually a custom transform, and you'll see that the value that I'm manipulating is this one here, so I've replaced it with a value. And what happens is each time the user clicks the Skew button, it increases the Skew value and then applies the Skew transform, so you can really see what it does. And that Skew value is initially set to 0. So the first time I don't think it does any skewing at all, and then as you increase it, and this probably could be a floating point number because it increases pretty drastically. Okay, so let's go ahead now and see what the Skew does. So I'll start the feed, and now I'll click the Skew, and you can see that it's skewed a little bit. We'll click it again. again, again. And so you can kind of see that what the Skew is doing is it's kind of suggesting a three-dimensionality to the rendering here. So it's kind of cool. Again, reload. Kind of works nice because I can click it between the interval where it renders, so it ends up choosing the Skew. Now I'll probably put together a little video where we play with the other parameters of the Skew as well, but I wanted to just go ahead and show you this. Connor had been playing with it in his program and mentioned it to me, and I asked him to share it with me. Okay, I think we're doing fine. That's a video wrap. And I hope you're enjoying these. I'm sure you're learning a lot myself. Sometimes feel guilty that it seems like I learn more than you